Here we are, the final question of Stats Mechanics, Year 1, question 11. Challenge questions, question 2. This is the last question out of the entire Year 1 syllabus. Okay, so what do we have? A particle travels in a straight line with an acceleration a given by a equals 5t plus 2. So we've got acceleration is equal to, not 5t, 6t plus 2. Very nice. Okay, particle travels 50 meters in the 4th second. The particle travels, it does 50 meters in the 4th second. Now they've worded that strangely, so presumably between 1, 2, 3, between 3 and 4, it covers a distance of 50 meters. Okay, find the velocity of the particle when t equals 5. Okay, well that's an interesting one, isn't it? So we've got the acceleration. Let's go find the velocity first. So the velocity of this particle is going to be the integral of the acceleration, which is going to be the integral of 6t plus 2 dt. And that's going to be 6t squared divided by the 2 plus 2t plus the c. Okay, velocity equals, what's that, 3t squared plus 2t plus c. Now then, if we want to know the velocity at t equals 5, we need to know what c is. How are we going to find c? We know that we have travelled a distance of 50 meters from here to here. So if we find out a formula for distance, let's do that. So distance is equal to the integral of velocity, which is equal to the integral of 3t squared plus 2t plus c. Now, will that work for us? In terms of this, distance over time, using a DST triangle, we know that we have done a distance when we have done 1 second and we've got 50, we've got speed. The speed is equal to your 50 over 1, but that's with variable acceleration, so we can't use that, so we need to ignore it. But can we use it to say that at this velocity we have accelerated? Maybe we could do suvat on it. Let's have a think. We could try integrating even with the c on it, because the integration is straightforward enough. We end up with 3t cubed over 3 plus 2t squared over 2 plus ct plus another constant k. Okay, which was, and that's a S formula. Now then, we know its distance. Let's just pretend its distance was 0. But its distance is 0 plus 10 at 4 seconds, from 3 seconds to 4 seconds. So I wonder if that gives us enough information to make it not 10 but 50 meters in the 4th second. So if we pretend for a moment, let's just take a datum as the distance is 0 when, in fact, let's just tidy this up first. S equals t cubed plus t squared plus ct plus k. Okay, now I am going to suggest to you that a distance of 0 when t equals 3 seconds. Okay, so if I have 3 cubed plus 3 squared plus 3c plus k, that I can make an equation that says, let's write it as, with a calculator, so 27, 3 cubed, 27, 27 plus 9, 27 plus 9 plus 3c plus k, so that's going to be 36. So minus 36 is equal to 3c plus k. Now I'm also going to say that at t equals 4 seconds, 1 second later, in the 4th second, there it is, 4 seconds, that we have made a distance of 50 meters as per this starting things. So I can say that my distance now is 50, that datum of 0, is equal to 4 cubed plus 4 squared plus 4c plus k. And so 4 cubed is 64, 50 equals 64 plus 16 plus 4c plus k. And so if we do 50, take away 64, take away 16, we get minus 30. And so we've now got minus 30 is equal to 4c plus k. Using a solver on them, which is on the calculator, I can do simultaneous equations and say that, where is it? Equations, simultaneous equations, number of unknowns 2. Okay, so I've got 3c plus 1k is minus 36, and I've got 4c plus 1k is equal to minus 30. And that tells me that c is equal to 6 and k is equal to minus 54. With that in mind, I can now come up here, take this equation, which is velocity, and rewrite it as 3t squared plus 2t plus 6, and the velocity when t equals 5, is 3, 5 squared plus 2 times 5 plus 6, which is equal to 3 times 5 squared, wrong setup, 3 times 5 squared plus 10 plus 6 is 91 meters a second minus 1. That was a nice question. Okay, devil in the detail of the question as always, 50 meters in the 4th second. So you knew at 3 seconds it could be an arbitrary amount, and in the 4th second, 50 meters more. Done. Okay, that was a nice final question to finish it off with. Being New Year's Eve, I wish you Happy New Year. Have a good one.